All right, we're ready for our next session. Melody and April from Paleotronic will tell about the MicroM8 emulator and upcycling classic games. Take it away.
Okay. Well, 2 years ago, we were at KansasFest and we demonstrated kind of an earlier, more primitive iteration of this called Disco Runner. And
Purple 8.
Oh, was it Purple 8 even?
Yeah.
Okay, well, it's had a few name changes. but it was basically an AppleSoft basic interpreter that we had created to allow for the running of AppleSoft basic games, but with 3D rendering and with the ability to add additional functionality through additional commands. Our reasoning was there's such a large amount of software for BASIC that if we could get younger people in particular more interested in, taking those programs and maybe playing with them and, trying to get them, more interesting, right? So an example of that is the original integer basic breakout. So I'll just fire this up, right? So with the basic interpreter, you could make it 3D, and it's the original program that's running.
Whoa.
Wow.
So if I go into text mode, you can see that it's the original basic program. You're in the way.
Oh,
Sit down. Okay, so then we moved on. We found some basic programs that had machine language components. So it's like, okay, well, now we need CPU. So we created the 6502 CPU so that we could run those little machine language routines for sound that come with the basic programs. And then, it just sort of became the next logical progression to be able to load a single load binary into memory, and then execute it through the AppleSoft interpreter. And so we did that. And then, well, heck, we've gone that far, so why not create a full-blown emulator, right? And so we eventually did manage to implement full emulation. And so and at that point, it just sort of grew from there. So I'll take you on a bit of a tour of what we've got so far. So if I go back to, I'm just going to go back to the main starting menu. So MicroM8 is broken up into a few different components. We have the emulation, which if you execute a disk image or a WAS image, it boots into an actual full-blown emulator mode and boots the disk and so on and so forth. But we have a few other modes in terms of, we have the AppleSoft basic interpreter, an integer basic interpreter, we have logo, and we have a monitor assembler. Now, logo is also fully re-implemented. So a typical logo is just,
Do show turtle.
Oh, okay. Do I need to do that? Okay.
Yeah, it's probably my fault. I break things. It's my job to break things.
Someone has to do
Exactly. Keeps me in a job, then I fix things.
Okay. Okay. So a normal like logo graphic could be something like that, right? But because this is OpenGL, we realized that we could do something like that.
Oh my
And then sit there and. So 3D logo has the potential to be a lot of fun. And it's also, I mean, it's a full-blown logo implementation, not just the turtle graphics. For the last issue of Paleotronic, April wrote a Space War implementation in logo. So you can, oops.
Had to have thrust.
Which is pretty cool for logo.
Sweet.
Let me kind of get that to where I am. So in terms of the actual emulation, okay, so why would it let me? Oh, there we go. So in case you're wondering, the file library here is built into MicroM8. So you have a local folder that contains all your stuff, and that's actually on the system in the user direct, like on your system in your home directory. There's an actual folder called MicroM8 that lives in your home directory. That gets created, and that's where you sort of interact with. So, that's where you put files that you want to interact directly with in MicroM8. You can just drop files onto MicroM8, but now the this Apple II directory. There we go. This is actually on the net, this is on our server, and every copy of MicroM8 can just access it. It just accesses it when it starts up, and it's got all kinds of. It's got a fairly large file library on it, somewhat like a bunch of WAS images and a whole lot of disk images and basic programs and so on and so forth. This is booting a WAS file, and ours warps it warps the loading so that it doesn't take forever. Bad Dudes is particularly long-winded. Okay, so oops, back from the detour a bit. So there's 3D logo, but there's also the basic interpreter also has 3D graphics modes in it. So these are just a few simple demos. So this one allows you to. We have several graphics modes. This one's 256 by 256 by 256.
We call it Cube GR for want of a better name.
And you can draw, you can do rays as well. So there's a lot of potential there for whoever wants to play around with that sort of thing. But okay, so to maintain compatibility with AppleSoft Basic so that you can load an AppleSoft Basic program and run it, AppleSoft has weird limitations with regards to variables and that sort of thing and commands. So you can't just willy-nilly start adding commands to AppleSoft Basic and then expect existing programs to work. So the way you get around that is by, the way we got around it is by creating commands that start with an @ symbol, because then the AppleSoft Basic interpreter can deal with those separately, and it doesn't affect the parsing of a traditional AppleSoft Basic program. So in this case, we've created a command called cube line that draws from 3D coordinates to other 3D coordinates, and with the color. Now this gets interesting once we get into the idea of what we call a micropack file. A micropack file consolidates, it allows you to consolidate code and media and what we call control programs into one file for execution. Now, a control program is what basically, a control program allows you to communicate and then affect an existing running file, like, or disk, or what, anyway, I'll just show you. So this is Montezuma's Revenge, and it's just running the normal Montezuma's Revenge disk. Control program's not running. That's weird. Things always glitch out when you demonstrate them. It's Murphy's Law or something. So while I was restarting, the Mockingbird music is actually playing back from a stream that's recorded. So we've put functionality into MicroM8 where you can record Mockingbird music from another application that's running, and not an audio file. But because of the nature of MicroM8, MicroM8 is written in Go, which means most emulators go on a loop, right? But Go is time indifferent, so you can't really use a loop because you don't know how long it's going to take to do anything. So as a result, everything's broken up into separate threads. And so there's a video thread and a sound thread and a CPU thread, and all of these threads interact with each other in order to do the actual emulation or the basic interpreter or that sort of thing. So as a result, when we went to implement Mockingbird support, we couldn't actually emulate the sound chip fast enough or accurately enough. And so what we did instead was converted the instructions that are being sent to the Mockingbird into instructions that then we have a synthesizer that then plays the Mockingbird sounds. But that way, each channel is at 48 kilohertz, and it mixes properly with the PC speaker, like with the Apple speaker sound. So unlike with Apple Win, there's no dropouts when there's both Mockingbird and the speaker sound, which is kind of cool. That's how it work this time.
Yeah, it's going to.
It's going to. It's not. Oh no, there it goes. There we go.
Wow. Oh, beautiful.
So there's a lot to pack in here, I guess. The HDR pixels are rendered as 3D voxels, right? And they're offset. So we've set up the system can offset the various colors forwards or backwards in order to create kind of a textured effect. Like you see how there's the red bricks are sticking out from the white. Now the colors have been remapped, so obviously these are not the traditional HDR colors. So we put in functionality so you can redefine those colors to be whatever you like. And there's a background, obviously, so you can load in a background file and put it behind the scene, and you can either have it move with the model or not move with the model. It's kind of up to you. Now, a lot of this functionality is being done by a control program. So, if we look at the control program, so first we have these. Okay, so this command at the top tells the control program, which is running in a second slot we call, or virtual machine. So MicroM8 comes with 8 different virtual machines that you can run simultaneously. And each one of those virtual machines can communicate with other virtual machines. So this VM redirects command basically says this program is going to affect the first slot, which is Montezuma's Revenge. And so then we have a number of things. It sets the aspect ratio. It sets the depth of the various colors. So basically the size of the voxels that it's drawing. And then we have color remapping, camera zoom, the backdrop. So montywall.png is stored inside the pack file container. Set the opacity, and various functions. These functions make it so that the backdrop moves with the model. And then we read the system panel. So we read the joystick, and then use that to tilt the camera orbit command. And all of that comes together to give you this effect. So I'm moving the character with the joystick, and as a result the model moves at the same time. So a similar example, for example, is Robotron. And all of these files are on the server, so if you download MicroM8, then you can just go into the MicroPack folder, and they're there. And this is the two-stick version of Robotron. So. So what other interesting things can you do with micropacks? So another thing you can do is you can enhance existing games in other ways. So this is going to take a second to load, but this is Zork. It's a that's kind of cool, right? So there's two things working kind of together here. So there's the control program that we're talking about. Now this basically, we have a command that April created, like a function, and it's screen read. And so it allows you to look at the screen of the other, like, running emulator and go, okay, well, what's at this location in the screen? And so, based on the location, we set a different background image, right? That's called, upcycling a game. Now, there's two things. The other thing that's happening here is inside of the micropacks themselves, because you might not want to write a control program every single time. So if I go into the micropack file for Zork, you can see that it's got the various PNG images for the different parts of the game that we turn in. This is just a demo, so there's only like 8 of them or something. But there's also these CFG files here, these configuration files, and you can you can edit them through the built-in editor. I mean, everything's built in, of course. And it allows you to set various parameters. For example, we can set the stereo balance of the Mockingbird implementation, because we can do that. and the speaker mix, and the music sound source, and so on and so forth. So this is the sound, the audio configuration, but there's also like video configuration. Oops, not a disk. And that allows you to set things like the camera position and background color and the backdrop and things like that. So a lot of this stuff you can configure through these config files without actually having to write a control program. Or you can write a control program. It's all up to you. Now, creating a pack file is fairly simple. You just basically go and find what you want, and then you just press Control-Shift-P on it in the catalog, and then it creates the pack file in your home directory with a whole bunch of default configuration files. So you can just go in to the local directory, back up the top, and then it's down here somewhere, packer, and then it's fresh and new, and then you can just go in and change the settings to the way that you want. The other thing you can do to create a pack file is you can actually start a game. Oops. There we go. Sense wave. Gonna boot. Doesn't look like it's gonna boot. That's embarrassing. Oh, maybe because. We might have.
So didn't want to let go.
Yeah. We might need to log that.
I'm logging.
Alright.
Yeah.
Okay, so to create another pack, to create a pack so the other thing you can do is use the built-in control keys to configure what the screen looks like and such before creating the pack. So in this case, you can make it turn on the voxels, you can change the depth of the voxels, you can move the camera around. Zoom out a little. And then once you've done that, then you can sit there and go and create the pack file. And then the pack file will be created once again in your local directory, but with all of these settings saved. So I did this with, I did this with, I think I did it with Jumpy Guy. Oh no, yeah, I did it with Jumpy Guy. So Charles Mannion's game that he just released. This is sort of the MicroM8 version, the upcycled MicroM8 version.
Nice.
Oh, wow.
Wow.
Oops. And
Very good.
and Degenbrock's Flappel Bird. So this is a good example of actually offsetting the pixels in order to create a 3D effect. So based on the different colors, so we offset the yellow and we offset the blue, the greens, and we move back the blue and just kind of shuffle stuff around, and it creates this kind of 8-bit, like 3D-esque effect. But nothing's been changed with the original game. The original executable is still the same. It's just emulator configuration that's doing this. And once again, we have a control program that's just doing a simple swaying. It's just doing a simple swaying effect with the camera, just to kind of keep things, moving and interesting, and allow you to change the perspective a bit. So another thing you can do is you can hook in, like with basic programs, and you can do it with machine language programs too, but we haven't actually personally delved that far into it. But this is an example of a basic program that has a control program and how they can like seriously interact with each other. So this is just integer basic pawn, right? But it's got a bit of a twist. So whenever it detects that the wall changes, it changes the side, right? Now, so how it's doing this, oops, is the program. I modified the program slightly in order to use poke statements to set memory values in a location that the control program can then look into and kind of use as signal flags to say what we're doing. So we set the memory locations basically to indicate the direction the ball is going, so that the control program can then, while it's running, it's looking at these memory locations, and then when it sees that they change, it goes and moves the camera over to the other side of the play field. So a few simple changes to a 30-year-old program. Oops. Oops. Can't type. Anyway, can't play Pawn either. What's another good one to look at? Miss Pac-Man's a good one to look at too.
If anybody's got like Trevicam or Gravel that they need to take, I suggest you take it now.
Okay, so one of the complaints with older games is that they're kind of pedestrian by today's standards, right? So one of the things you can do is just like, one of the things MicroM8 can do is do things to try to make them more challenging.
Controlling it backwards and upside down is a lot more difficult than you think it is.
Now, of course, since you can, since we've opened up full control of the emulator and the associated memory, another thing you can do is cheat. So this is one method of cheating. This image takes it takes a little time to load for some reason. It's burger time. It's getting there. Oops. Yeah. So this isn't, this is a clean crack. I think it's 4 AMs, and it's not. It doesn't have any trainers or anything like that in it. Oh, there it goes. So my shifts, I still have 5 shifts, so should still have 5 shifts. Yeah, I do. I still have 5 shifts. So that's inside the control pack once again, in the hardware section. So if you go into the hardware section, then there's this section called memory locks. And basically what the memory locks allow you to do is set a particular address to a particular value. So in this case, we tracked down what that address was. April can explain how we tracked that down.
Yeah, so even a couple of years ago we had a recording feature, and that records memory and that kind of stuff. Now, we've got a command that can analyze that, and you can say, I know there's a life counter and it goes 5, 4, 3, 2, 1 when I'm playing it as it decrements. So you can make a recording and then analyze that, and then it will look for those patterns in memory, and it'll say, oh, okay, here's the location that's decrementing in that particular sequence, for example. So in that case, what we've done is just to say, once this gets set to 5, lock it at 5. So any attempt to write to that location will just be silently ignored. And the reason I said when it gets written to 5, because when you're loading games, some of these things use the same memory for like decompression and loading and stuff like that. So you don't want to lock it right at the start, because that could be bad. So it's like an offset, time offset thing.
Okay, so about that recording, right? So I'm just going to go back to Jumpy Guy, I guess, because he's a quick game to load. So early last year, we implemented what we call Live Rewind, which is a recording feature. It's basically designed because I suck at games, so the idea was that when I die, I can rewind the function, like rewind the game, and just rewind it as many times as I want in order to not die.
So it's probably worth mentioning at the moment, all the hardware rewinds. So for example, you can load up DOS, you can like save a file, turn Live Rewind on, you can delete that file or save over it, and you can rewind, and it will also rewind the disk bit stream. So that when you get back to that point and jump back out prior, similar to saving a life in a game, the file will be back on the disk.
So if I turn rewind on,
Yeah, you'll notice you get a little recording icon, and that's active.
okay, and so if I rewind now, then
Yeah, rewind the audio as well.
speaking of audio, I'm going to take a quick diversion just for a second because
How are we doing good time?
you should probably talk about just me for a minute. Where are we at?
About 10 more minutes.
Okay.
8 minutes.
8 more minutes. Okay, so there, that one. So this is something I'm going to demonstrate something we're pretty sure you can't get anywhere else if you really wanted to do such a thing. Actually, I don't know that one. Okay, so because of the way we implement the walking board, you can do this.
So the audio generation, because we're using the synthesizer, it's decoupled from the synthesizer.
Okay, so there's a million other things I could show you, but if you go to this, you've gotten a pretty good taste of it. So if you go to the website and download it, you can play around with it. We also support color printer. We support color printing through Print Shop and other things. And we have a virtual what we call a virtual modem that allows you to connect to things through ProTerm. So over the internet. So, oops, and it crashed. All right. So,
That's me.
Okay. So did you want to take a couple of minutes to talk about DiskMate and
Oh, just quickly, I haven't got too much of a demo, but we also have a product. Charles has actually been using it. It's called DiskMate. Basically, we open sourced the code we were using for handling disk images and browsing them in MicroM8, and you can use that to kind of edit disks and add files, remove files, extract them, modify disks, and things like that. So there's, I think there's a section on the website for that. Yep, there's a section on the website for that, so that's on GitHub, so we can set the link out for that.
yeah,
Yeah.
the major thing about DiskMate is it allows you to scan through a collection. Like what sets it apart from Apple Commander and stuff is it allows you to actually scan through a collection of disks and analyze them to determine which are dupes or which contain, say 95% of the same information, so then you can weed out duplicate disk images. And, it does a lot of other funky stuff too, but that's probably the most interesting.
That would take a whole session in itself to walk through that.
Question?
Yeah, do you also have a magazine subscription that's starting up?
Oh, yeah. So the last thing, we're almost out of time.
Not too bad.
So we did bring 50 copies, 25 of each of our first 2 issues. So if anybody wants to
Well,
grab-
you just hand them out.
Yep. All right.
One per person, just distribute them randomly. So yeah,
We might not have enough for that.
well, one
Yeah.
per, okay, and they run out when they run out.
Yeah.
Sell them.
So I can't sell them.
We're not allowed to sell them because we're.
Immigration will get
Tourist
upset
visa.
about that.
Oh, yeah.
So,
Or second one, what if a donation?
no, just
What if Steve sells them, and what he does with the money after that is
Now,
completely between
if you want more information, you can go to the website and do things there.
What is the address of that website?
Paleotronic.com.
.au.
No, just.com.
Oh. Never mind.
Now, okay, so several months ago, I guess about a year ago, I got an idea. Like, I wanted to bring back a more classic computer technology magazine that looks at the history of computers and video games and other technology, and just kind of provides a more modern context or packaging to that information. So the magazine kind of grew out of that. And so issue 3 is going to be coming out at the end of this month. The first issue was about the Consumer Electronics Show. The second issue was about the history of television and video. And then the third edition is going to be about the moon landing and have associated articles related to that, such as basic lunar lander and video games that were related to the moon and so on and so forth. Now the first issue has an interview with Steve Wozniak in it about the Disk 2. And the second issue has an interview with Spectrum engineer Richard Altwasser. And yeah. So if you're interested, I can't ask you to subscribe, but what I can ask you to do is go and take a look at the website. And the website, the articles get posted on the website basically 2 issues behind. So we've posted most of the articles from issue 1 are posted on the website, and it's been up for 3 months, and it's got like 80,000 views, which I think is pretty good. So for 3 months, and subscriptions are gradually pouring in, so it looks like we'll be good for at least a few more issues.
This is beautiful.
It really is.
All right. Oh, well, I need water, so I guess that's it for me. Any questions?
Yeah, Melody, it's there's amazing like complexity and power, with the scripting and everything. Is there any documentation for anyone who wants to come in and learn the system?
Yeah, there's some articles on the website in the help folder in terms of there's a quick start, and then there's an article about the micropack, like how the micropacks are designed and configured. The thing that we're missing currently is a comprehensive explanation of the app functions, but we're hoping to get that up by
Like a
tonight.
command reference.
Yeah, so the command reference will be up tonight. We've been kind of lazy about it because we've been constantly developing and adding new commands and that sort of thing. But
Just one other quick question. The backgrounds for the Zork one, where did the art assets come from?
oh, those are just example ones that I pulled. They're not
But they were so Zorky.
Yeah. I think some of them are actually from a 3D version of Zork.
Oh, okay.
But it's
Like just screenshots that people
yeah,
uploaded from a different game.
Yeah. But it was meant more as a demonstration than an actual.
Okay.
Yeah.
It just works so well.
Yeah, it does. Yeah, it does. So text adventures can be upcycled that way, and yeah. Any other questions?
Do one more question, Chris? You had one?
Oh, yeah.
Yeah.
So, if, what's the license for the MicroM8? If you wanted to distribute that with, like, your own game or something, would you guys?
Oh yeah. It's just non-commercial. Like so we're the only people that could ever attempt to try to make money off of it. But if you wanna package it up, we can do that. But you would be best to contact me if you want an actual packaged game. Contact us and we can certainly do that for you.
All right, thanks.
All right.
All right, thank you so much.
Yeah.